Here's a question about electron configurations. They want us to be able to read the periodic table carefully and place an element in the right place. So question A, the third element in group 7A. If you look at your periodic table and the modern numbering scheme for the groups, it goes all the way left to right, and you would probably see group 17. Well, the old numbering scheme said group 7A. Group 17 and 7A are exactly the same. When we write this electron configuration, they want us to use the noble gas shortcut. So the third element in group 17 or 7A would be bromine. Bromine falls in the 4p sublevel, and it's the fifth element over. So I know that its ground state electron configuration ends with 4p5. I know that the noble gas that precedes it is argon, so I'm going to put argon in brackets. But then what other sublevels precede bromine but follow argon? To figure that out, we can just list out the sublevels that exist and use a simple trick for finding the order of fulfilling them. We know that there are as many sublevels as is equal to the value of the principal quantum number. You could list every single possibility, but students, they're not going to ask us about ground states for elements that aren't often seen. So I'm going to kind of tail it off beyond a point that we don't really need to go. So if you ever want to know the order for filling sublevels, make this sketch and then draw strike-through lines. And that shows the order in which sublevels are filled, starting with 1s and then going all the way down. In this case, we're ending with 4p5. Well, the 4p sublevel is right here. What directly preceded the 4p sublevel? The 3d sublevel. And it must have been filled in order to even get to the 4p sublevel. So I'm going to write, before 4p5, I'm going to write 3d10. And what preceded the 3d sublevel? The 4s sublevel. How many electrons fit in the 4s? 2. So my configuration for bromine is argon, 4s2, 3d10, 4p5. Next question. They say the as yet undiscovered element number 117. It's been discovered by now, actually, but that's neither here nor there. Where does it fit in the periodic table? It's still in the halogens, group 17 or 7A. It's just further down. This one, element 117, would fit in the 7p sublevel. And since it's the fifth element over in that sublevel, I know that it's going to end with 7p5. Which sublevels precede the 7p? Well, let's go back to our strike-through lines. I'm going to draw another one because we got to a point where we haven't gotten to it yet. So 7p, directly before that, is the 6d sublevel. 10 electrons can fit in the 6d sublevel. So I'll put 6d10. Preceding 6d, 5f. How many electrons can fit in any f sublevel? 14. So I'm going to write 5f14. Before the 5f sublevel, 7s. Up to 2 electrons can fit in any s sublevel. And then directly before the 7s sublevel, we have the noble gas radon. So it's radon, 7s2, 5f14, 6d10, 7p5. Problem C is a really interesting one. They say an element with 3 unpaired 5d electrons. I'm going to draw an orbital diagram for a d sublevel. And I'm going to draw it 2 different ways. And in both ways, we'll fulfill the requirement of having 3 unpaired electrons. So one way is straightforward. You can have just 3 electrons in the 5d sublevel. The configuration would end with 5d3. That's the case for the element Ta, tantalum. So a valid answer for this question would be a ground state configuration that ends with 5d3. And then if we go back to our strike-through lines, the preceding sublevel is 4f. So I'd have 4f14, and preceding 4f14, 6s, 6s2, and then directly before that is the noble gas xenon. So for tantalum, a valid ground state configuration would be xenon, 6s2, 4f14, 3d10. But there's another possible answer here. What if we got 3 unpaired electrons by giving each orbital 1 electron and 2 of the 5 orbitals 2 electrons? This configuration ends with 5d7. We still have 3 unpaired electrons. For which element is this true? Iridium. So you could just as well have written, for the last part of the configuration, 5d3 or 5d7. Either one would be fine in the real world. Now, I think WebAssign accepts both, but I could be wrong about that. Lastly, in part D, the halogen with electrons in the 6p atomic orbitals. Okay, it's a halogen, so it's got to be p something. And they say it's in the 6p orbitals, so we know that it's got to end with 6p5. Looking at our strike-through lines. Which sublevels preceded 6p directly? 5d. So just before the 6p comes 5d, and up to 14 electrons can fit. Directly before, 10 electrons. 10 electrons could fit in a d sublevel. Directly before 5d is the 4f sublevel. That's where 14 electrons could fit. So 4f14, and directly before that, 7s. 7s2. And directly in front of the 7s sublevel, oops, excuse me, I got that one wrong too. Directly in front of the 4f sublevel is 6s. 6s, not 7s. And the halogen right before that is xenon. So it's kind of like the problem C. Xenon, 6s2, 4f14, 5d, this time it's 5d10, and then it goes on to 6p5.